Yeah, good morning, everyone. So we'll be shortly commencing this workshop on PDS, and Secretary Sir will join in a short while, whereas we are waiting for additional Secretary Ma'am to join. So the moment she joins, we'll be initiating these proceedings. So in the meantime, I'll request all participants, August participants, to kindly put their mics on mute mode, and during the presentation process also, and during question answer session, everybody is welcome to interact with the presenter as well as with the other persons. Thank you.
A very happy morning to everyone. Mahendra joined from Nola Foundation.
Good morning.
बैग तुम्हारा ऊपर ही
Good morning, ma'am. Ma'am, actually, you are not audible.
Hello, sir. Morning, sir.
Good morning, Tyagi sir. Good morning, everybody. Am I audible?
Good morning, ma'am. Yes, ma'am.
Ma'am, actually, we got message from Secretary Sir's office that he'll be joining in a short while, and he has asked to start the proceedings. So, with your kind permission, shall I?
Please start. Please start.
Okay, thank you, ma'am. So,
आवाज कम
honorable.
आ रहा है, आवाज कम
Hello.
आ रहा है, आवाज कम आ रहा है सर.
Okay. Now is it okay?
No, sir.
It's okay
Still
for us.
it is required.
No, it's okay for us. Maybe the volume.
It's okay for us, sir.
Okay, fine. So, Honorable Additional Secretary, ma'am, Joint Secretary Administration and Project Coordinator for the NHP, Director NRSC, Director NIH, other senior officers from Government of India and the states, experts from the academia, research institutions, as well as NGOs. On behalf of National Hydrology Project, a very good morning to all of you and a very warm welcome on this workshop on PDS, which is a web-enabled GIS-based spring information system for vulnerability assessment as well as for the hydrogeological investigation of some of the selected springs. The area which has been focused during this PDS study is the Ravi Basin and particularly the Chamba Basin, Chamba district. Simultaneously, we shall be using this event for releasing one of the very informative product prepared by National Remote Sensing Center, NRSC, which is also our one of the implementing agency under NHP. They have prepared Glacial Lake Atlas for the Indus Basin that will be released by Secretary Sir. And immediately after that PDS session, that Glacial Atlas will be released. Both these products, that means this PDS as well as this Glacial Lake products, are the outcome under NHP. You must be aware that National Hydrology Project is a World Bank supported central sector scheme being implemented by Department of Water Resources, River Development and Ganga Rejuvenation on pan-India basis with involvement of 48 central and state implementing agencies. So one of the initiative under NHP is the PDS. PDS means purpose-driven studies. Basically, PDS, it is an initiative to address some of the specific problems related to water resources management in an identified area. And NIH has taken the lead as a coordinator for PDS. I can say that basically PDS provides a platform for the researchers as well as the practicing professionals to work together for resolving some of the issues related to water resources management. So this is why we also call PDS to as purpose-driven support, not only study, because these are to be implemented. So it is the purpose-driven support. So it's not a simple research. It is to be applied to solve the real-time problems. So this particular PDS is going to be presented by Dr. S.S. Rawat, who is the principal investigator for this study on Himalayan spring. This PDS assume importance, particularly as we know that these springs are the lifelines or the major source of water for the Himalayan households. And in some cases, it is the sole source. Yet, due to not paying proper attention to these springs, so there have been issues with the springs. Some have been dried up and others are in the threat of drying up. So as a first step for rejuvenation of these springs, NIH has taken a small step towards this initiative for identifying, for mapping the springs and preparation of the web-enabled GIS-based inventory for the springs. I'll not take much time. I'll request Director NIH, Dr. Tyagi, to give some insight into the PDS initiative by NIH as well as this PDS, particularly on the spring mapping. Thank you, sir.
त्यागी साहब आपका म्यूट है. त्यागी साहब आपका म्यूट है.
त्यागी सर अनम्यूट कर लीजिए.
So, are you able to hear me now?
Yes, sir.
So, okay, I am sharing my screen. Are you able to see the screen?
Yes, sir.
Okay. So, on behalf of NIH and on my personal behalf, I extend my warm welcome to Secretary Sir, AS Ma'am, Joint Secretary Sir, Director NRSC, Madam Anju God, guests who are attending this meeting, and the entire team of NHP. Sir, NIH has been entrusted with 4 major tasks under NHP. First task is purpose-driven studies. And here the role of NIH is to receive the proposals, PDS proposals from implementing agencies, get them reviewed through the experts, and then coordinate the research activities and review and monitor the progress of these PDS. Then second task assigned to NIH is to plan and organize the training courses for the capacity building of the implementing agencies under NHP. And the third task is development of decision support system. In fact, a decision support system for planning was developed under HP2. Now, with a view to enhance the capabilities of that existing DSS, the development of DSS for planning and management is being taken up, and it is assigned to DHI India. And NIH is coordinating with DHI for its enhancement and for monitoring and reviewing the progress also. Then the fourth activity assigned to NIH is establishment of Center of Excellence for Hydrologic Modeling and to provide leadership to the country in hydrologic modeling services. And under this also, we have taken up development of a large-scale conceptual hydrological model, and this model is being developed by NIH jointly with IIT Kharagpur. Apart from this model development, we have also taken up a few more studies under this Center of Excellence. Then coming to the PDS, in fact, as was told by Mr. Kashyap, undertaking the purpose-driven studies by implementing agencies is one of the main focus of National Hydrology Project. And these PDS proposals were invited from the implementing agencies with the broad guidelines that the PDS should focus at specific issues and problems of water management that are identified within the area of operation of the implementing agencies. And for a PDS, the department or the institution or the agency that will use the outcome of the study should be clearly identified in the proposal itself. Further, the outcome of the PDS will be implemented by the respective states. And in some of the PDS, we are also organizing trainings for the state engineers for the capacity building. Then once these PDS are over, the workshops with implementing agencies and stakeholders will also be organized to disseminate the findings of these PDS. Then it is also envisaged that these studies will also be replicated in other study areas of the states. And in some PDS, mobile apps and web-enabled information system are also being developed. And finally, the outcome of these PDS would also lead to the publications or the research publications. We have a subcommittee on PDS that reviews and monitors the progress of the PDS. Earlier, these meetings were being held at 6-monthly interval, but now after July, we have started convening these meetings at quarterly interval, and we are rigorously monitoring the progress of these PDS. Then, as far as the status of PDS is concerned, in fact, about 110 PDS proposals were received from the implementing agencies. But some of the proposals were not found fit in the framework of the PDS. Then the PDS proposals were sent back for their review to the implementing agencies, and they were not received back. For some of the PDS, the title was not, was good as far as the PDS is concerned, and some were rejected by the review committee. So ultimately, 40 PDS were approved. Then in the 7th R&D session, 7th and 8th, which were conducted this year, 4 PDS were dropped because there was little or no progress in those PDS. So 1 PDS of Kerala, 2 of Gujarat, and 1 of West Bengal, they were dropped. So now we are left with 36 PDS, and 36 PDS are ongoing currently. Then in the 7th R&D session of the subcommittee, 7 PDS were recommended for taking up, but their approval is still pending. Then if you see the distribution, then out of these 36 PDS, 17 PDS are being carried out by NIH as the lead agency, and 2 PDS by CWPRS. Then remaining 17 PDS are being conducted by 9 state agencies. Then in 13 PDS which are being conducted by NIH, states or the other agencies are the partner. Similarly, NIH is also partner in 5 PDS which are being conducted by the states as lead agency. Then if we look at the completion schedule of these PDS, then 20 PDS out of these 36 PDS, 20 PDS will be completed in 2021, then 10 PDS in 22 and 6 PDS in 2023. Then besides these 36, we have also taken up 7 special studies under NHP, and out of these 7, 6 studies are being carried out by NIH in partnership with states. And out of these 6, 2 studies will be completed in 21 and 4 studies in 22. The 7th study is being conducted by Water Resources Department of Andhra Pradesh in partnership with NIH, and that will be completed in 2022. Then if you look at the broad areas under which these PDS have been taken up, they include broadly the inventory and sustainability of natural springs, conservation and management of lakes, reservoir operation policy, reservoir sedimentation, droughts and desertification scenario, then assessment of surface water quality status and mitigation measures, characterization of deep aquifers and aquifer mapping, groundwater dynamics in coastal aquifers, evaluation of the arsenic affected aquifers, water quality assessment and remedial measures, then groundwater salinity and source identification, river rejuvenation, effect of coastal process and seawater intrusion, then environmental impact assessment, evaluation of return flow, and leachate transport modeling. These are some broad areas. Apart from these, there are many other areas also. So as was informed by Mr. Kashyap, then one of the important PDS that has been taken up by NIH is on development of WebGIS based spring inventory for vulnerability assessment of hydrogeological investigations of selected springs in Ravi catchment of Himachal Pradesh. And under this study, a WebGIS based spring information system has been created using open source technology. And this information system, in short, is named as Ishwar, under which geospatial data of nearly 623 springs of river Ravi catchment has been created through field surveys. And such WebGIS based inventory will be of immense use for policy planners for sustained spring based water supply system and for revival program of the springs. So I'll not take much time here because this study is going to be presented in detail by Dr. S.S. Rawat. And now with the permission of Secretary Sir, if he has joined, I would like to invite Dr. Rawat for his detailed presentation of this study. So thank you very much.
I don't think Secretary Sir
Thank you.
has joined yet.
Okay, sir. Okay, ma'am.
So, but let us go ahead. Please go ahead and present the study. Thank you.
Thank you, ma'am. So I invite Dr. Rawat to present his study.
Thank you, Dr. Rawat. Please go ahead. Dr. Rawat,
Yeah, ma'am.
is there a problem? Okay.
शेयर नहीं हो रहा हो गया शेयर हो गया Hello, ma'am. Am I audible?
Yes, Dr. Rawat, you are audible, but we are not able to see the contents.
You're audible, but we can't see your screen.
Dr. Rawat, is there a problem in sharing the screen?
सर आपने अनशेयर कर दिया अपना स्क्रीन?
हाँ, अनशेयर कर दिया मैंने तो.
You open the presentation, then yeah.
Yes.
It will now.
नीचे
Oh,
PPT
it's
हाँ जी, नीचे वाली टूल बार में जाइए.
There is an icon down below for the people.
हाँ बस
yeah.
It is visible.
Yeah, now it is visible, sir.
yes.
Please.
Okay. Good morning. Namaskar. सभी को अभिनंदन. Honorable Secretary sir, Additional Secretary Madam, Joint Secretary sir, Dr. Himanshu Kulkarni sir, Director NIH, Director NRSC, Dr. Anju Gaur ma'am, different officials of ministry, faculty from different universities, officers from central and state government department, and professionals from different NGO like PSI, Aquadam, Gram Vikash, and NOLA Foundation. On behalf of NIH, I, Shobhan Singh Rawat, welcome to all of you in this stakeholder workshop. And I am thankful to Secretary Sir for giving his valuable time to me type of young scientists. It's really encouraged us. And Honorable Secretary Sir, we are really grateful to you for disseminating water literacy in the country among the common people through your innovative ideas such as Catch the Rain campaign, Water Talk, Water Heroes Award, and Jal Shakti Abhiyan. Due to these activities, now people are understanding the recharge area, that is aquifer, is more important than the discharge point of a water source. And this is also reflecting in our coming National Water Policy 2020. So basically, we have National Institute of Hydrology is being carried out a string-based purpose-driven study in Ravi River catchment of Himachal Pradesh since 2017. And the major objective of this study is to create a web GIS-based information system, which was actually the major recommendation of NITI Aayog report, which released in 2018. Along with this, with the help of this inventory, we will identify some vulnerable springs, which is really needed, urgent needed, and then we will develop some adaptive measures for those vulnerable springs which have been high social importance. So in this regard, I am presenting this study, and this is the summary of my presentation. That first of all, since spring is relatively new area in research, particularly in hydrology field, so I will discuss some issues related to springs and their role in sustaining water supply in mountainous area of India, and some regional problems and consequences of drying of spring. And then I will discuss a 6-step methodology that I have given the name of cubic meter approach. M for motivate, M for mentor, and M for monitor, which is we have evolved or adopted in this particular purpose-driven study. Then I will, if time will permit, I will give the demonstration of a data collection system which we have made in Cobalt Toolbox, which is basically open source technology. And then finally, most important thing, that we will give the demonstration of our web portal that we call actually Sure. Since these springs are considered as sacred places in the entire Himalayan region, and these are considered as abode of God. So we have given this name as ISWAR, means Information System of Himalayan Springs for Vulnerability Assessment and Rejuvenation. And then finally, we will take your feedback and suggestions so that we can make this information system more visible and more attractive, and so that we can get some fruitful outcome from this study. Now, before going to presentation, I would like to share this slide, which we motivate to work in the field of springs. Actually, collection of water for the daily need is a full-time job in entire Himalayan region, and this job is generally done by women and children. And our secretary sir rightly said in different meetings or workshop that women are the most sufferer of water scarcity in the country. अगर जयशंकर प्रसाद जी की शब्दों में अगर यहाँ की महिलाओं की दुर्दशा को बयां किया जाए तो हम कह सकते हैं, हे पहाड़ की नारी तेरी यही कहानी, आंचल में दूध सिर पर पानी. So the innocent eyes of these women asked us why I have not fulfilled my all dreams, because she has spent a lot of time to collect the headload of water. So this is the brief of project. The title of the project is Web GIS-based spring inventory for vulnerability assessment and hydrogeological investigation of selected springs for sustaining local water demand in Ravi River catchment of Himachal Pradesh. The total area of catchment is 5,400 square kilometer, which is almost 10% of entire Himachal state. And the lead organization is NIH, and our partner organization is Himachal Pradesh Jal Shakti Vibhag. And total budget of this PDS is 69 lakh, and till today we have spent 39 lakh. And duration of this project is 4 years, and which was actually started in September 2017. And myself is the PI of this project, and there are 4 co-PIs, that is Dr. Sudhir Kumar, isotope experts, Dr. PG Jose, water quality expert, Engineer Suman Gujjar, computer scientist, and Engineer Deepak Singh Bist, GIS expert. So if you will see the demographic pattern in entire Himalayan region, so most of the population of IHR is spread in lesser Himalayas between 1,000 to 2,000 meters. If you see the altitude of different hill stations, you will find that all hill station is located between this altitude. And the topography of this lesser Himalayas is such a way that rivers are flowing in deep valley and glaciers are in far flung area. So the water from these sources are not easily available. So local springs are the dependent source of water supply in the lesser Himalayas areas, and every hamlet or every village is located near the springs. So there is spring civilizations in entire Himalayan region. Actually, spring is it is a hole or fractures in ground from where groundwater comes in the form of spring at Earth's surface. And these are known as by different name in entire Himalayan region, like Chashma and Nag in JNK. You might heard Anantnag, that is infinite number of springs. You might heard Berinag, that is the source of mighty Jhelum. And Chumik in Ladakh, Paniahara, Nadu, Bauri, Chireu in Himachal Pradesh, and Dhara and Naula in Uttarakhand, and Dhara also in northeast area. So if you talk about the dependency of spring, 50 million people of 95 districts of Indian Himalayan region, that is from 9 states, 2 union territories, and 2 hill districts of Assam, and 4 hill districts of West Bengal, are totally dependent upon these springs. And even not only in hilly areas, even in downstream areas or plain areas, these springs act as these springs maintain the base flow of these rivers. You can take examples of Ganga River, that at Gangoti, at snout of Gangoti Glacier, the entire flow is contributed by snow. But when we reached downstream site at Depariyar, the snow contribution remained only 25%. However, subsurface or spring contribution become 56%. And we know that Ganga is declared a national river, and it is a river of life and river of death in India. So the future of Ganga is depend upon the future of these springs. So if you in last 2 or 3 decades, due to some anthropogenic activities and which is exacerbated by climate change, these springs are drying at very fast rate. Especially one of the survey conducted by Himachal Pradesh Council of Science, Technology and Environment, that 70% of springs of Himachal Pradesh are in poor conditions. And especially you will see from this graph that almost all springs of Chamba town, Chamba districts are in poor conditions. In this, keeping in this view, Planning Commission, which is now Niti Aayog, has given stress to constitute a special cell in the state for regular monitoring of these vital water resources. And same kind of problem is happening in entire Himalayan area from JNK to Arunachal Pradesh. And these are some consequences of drying of springs. You can see long queue of ladies and children in Himalayan areas. Even people are putting log on their springs so that their water cannot be tapped. And People moves wherever water moves. Water moving towards plain area, and people also migrating in plain area. There are several villages in Uttarakhand or in other Himalayan areas which is completely vacant. So water scarcity is also one of the reason of this migration. And however, water scarcity is not the new problem. Even in the old days, there was water scarcity. Even you might remember that 500 years ago, Rahimdas said that Rahman pani rakhiye, bin pani sab soon. So, but in old days, there was respect towards these springs. These springs or these water resources considered as temple of God. And they planted a banyan or people tree or created a temple so that they can protect their springs from any encroachment or any pollution. एक कहावत है जल मंदिर की छाव में गंगा जमुना गांव में, and there are several festivals like Mathi, Harela, which is encourage afforestation in the catchment area. Recently, we have celebrated Chhat Puja, which is also celebrated near a water bodies. So, if these springs are so important, then why it could not become the part of our policy? So, you will see that lack of basic database is the major reason which kept springs away from our policy. We have good data on rivers, streams, ponds, lakes, glaciers, but unfortunately we don't have such kind of data on the springs. I have taken this table from Niti Aayog report, and I was also one part of that Niti Aayog report, and when we have collected different data from various state government and central government, and Dr. Himanshu Kulkarni sir proposed this table in that Niti Aayog report, and if you see that in Uttarakhand only 3.5 villages which have been springs. In Himachal Pradesh only 12.6% villages which have been springs. This is not possible because 90% of water supply of these states are depends upon the spring. So available database on springs are likely to be underestimated. So there is a major recommendation on Niti Aayog report, creation of a web-enabled database, web portal on which the springs can be mapped or geotech. All state government departments, RAD institutes and NGO working on springs and springs and management will upload data on the web portal. And what are the benefits of web-based spring inventory? First, to understand the present state of spring. Basically, there are several underestimates which say that 50% of springs have been dried up. There are 3 to 5 million springs in the entire Himalayan region. But basically, all these are estimated based on some small studies in Indian Himalayan region. So we cannot say that what are the actual data. So there is an urgent need of inventory. And second is local springs if we have inventory, we can cap local springs in consideration of expansion of our development activities. And if we know which springs are vulnerable, then government can allocate funds and priority of the states for implementing the springs and activity. And most important, if you have pre-project data, then we can assess the impact of any spring set program. What is the impact of that spring set program? So in past, there are few studies, projects spring set program have been successfully carried out, and Sikkim spring model is the best model, which is run by the Sikkim government with the help of different central and state organizations and some NGO. And under this scheme, 50 springs, 5 lakes, and 7 hilltop forest revived. And I have assessed this program. This was very excellent program, and I have estimated the increase in aquifer recharge. And lot of aquifer recharge, 89% and 111% and 133%. Some springs have been increased. But one thing I would like to submit here that we cannot copy Sikkim spring model as it is in other part of Himalayan areas, because there are lot of difference between Western Himalayan region and Northeast India. If you talk about the geographical area, the entire Sikkim state is 7,000 square kilometers. There are several districts in Western Himalayan region which is larger than entire Sikkim state. I am from Uttarkashi, which is greater than Sikkim area. So a small administrative body has to implement the government scheme project more efficiently. And same is population density in Western Himalaya. Population density is quite high, and normal annual rainfall, which is very important for spring revival. The normal annual rainfall of Northeast India is 2.5 times greater than Western Himalayan region, and even monsoon season is in Western Himalayan region is short, is low duration as compared to the Northeast India. And if you talk about duration of most extreme dry spell, which is 156 days in Western Himalaya, and in North India it is 80 days. Means there are maximum gap between the two consecutive rainfall. And if any springs having depletion time of 100 days, means once springs get recharged, how many months, how many days it can last. If any springs having depletion time of 100 days, then that springs is reliable source of water in Northeast India, but it could not sustain the water supply in Western Himalayan region. And most important, that attitude of the people. I personally believe that Northeast people believe in community-centric approach. However, we are some lacking in this regard, which is one of the key parameters for success of any community-based government scheme. So, keeping view in all these things in mind, we have started a project in Western Himalayan region, and the objective of this PDS is creation of web-enabled database of the spring emerging in the catchment based on extensive inventory of physical and hydrochemical characteristics and mapping of vulnerable springs and hydrogeological investigation of some selected springs which are vulnerable and having high social importance for identification of their springs recharge area and potential, and to suggest adaptive strategy for selected hotspot springs for spring sanctuary development to sustain the local water demand and to build capacity among the local stakeholders through creating para-hydrologists for conserving and managing the spring. So this is our catchment area, and there are some very interesting point about Chamba district. It is basically a hilly part of Ravi river catchment, completely falls in Chamba district, and almost entire Chamba district drains into Ravi river. Means when you are talking about the springs of Ravi river catchment, means you are talking about the springs of Chamba district. Second, Chamba district is geographical second largest district of the Himachal Pradesh, and it having a highest scheduled tribe population in the state. And it is basically most explored catchment because it is a first river under our part under Indus water treaty. So it is a most explored catchment in terms of utilization, but it is virgin in terms of research. And it is one of the aspiration district declared by NITI Aayog. And this is very important district that there is all 4 agroclimatic zones of the state found only in this district because the elevation ranges from 400 meter to 6,000 meter. So there are all.
Just a second, Dr. Rawat.
Yes, ma'am.
People who have their microphones on are requested to switch it off because we can hear some ambient noise. Please mute your microphones except the presenter.
May I continue?
Carry on, please. Carry on. Thank you.
So Chamba district is very, very important district. So we have selected this Chamba district, and this is the methodology we have adopted in this project. That this methodology is basically the intention of this methodology, how to increase the small discharge of any springs to a big discharge springs. So the entire methodology depend upon a cubic meter approach. Means we have to motivate the people that they can revive their springs, and then we will mentor some spring set program in the area, and then after once the people realize that they can revive their springs, at that time we will monitor all these programs so that people can do in so that people are going in right direction. So entire approach is based upon 6-step method. That first is spring mapping. We have to collect various data on springs for entire catchment, and then based upon the collected information, we have to identify the vulnerable springs, and then we will monitor the discharge and other parameters of these vulnerable springs and create some GIS database, and then we'll identify the spring set, recharge area of these vulnerable springs, so that adaptive measures or solution can be developed, which will be implemented by the state government agency. And last but very important, that what will be happen after completion of this project, how the objective of the project will survive after completion of this project. We have to create some para-hydrologists which can understand the hydrology and geology of the area, so that they can themselves revive their springs. So first we have take different topo sheets. Actually, Survey of India have demarcated some major springs. So we have demarcated survey of springs from Survey of India topo sheets, and we found that there are 224 springs in Ravi River catchment. We have digitized some glaze map so that location of springs can be visualized, that it is this spring is near this glaze, and this kind of activities are helpful. You can see that in this particular part, their spring density is very high, but in this part or in this part, spring density is very less. So this kind of exercise help us to deploy our manpower, so that when spring density is high, we should deploy more manpower. So we have recruited 4 field assistants, which is equipped with GPS, which having camera. This GPS is used to geotag the springs, and rest of the information filled in a paper sheet. And we have also recruited 1 GRF, which is the work is water quality analysis of these springs. And we have established a basic water quality lab at our Western Himalayan Regional Center, Jammu, because the location of Jammu is very near to Ravi River catchment, so that we can timely test the spring water samples. So we have established a basic water quality lab at Jammu Regional Center. And these are the different capacity building of field functionaries. We have give some training program of our field staff, so that they can read map, they can take data, they can do some basic water qualities in situ condition. We have also trained some field functionaries of Irrigation and Public Health Department of Himachal Pradesh, so that they can help our field staff. And we have developed a data sheets which comprises several more than 35 parameters, which is very relevant to the spring and this data sheet supplied to all these field workers. And then we have divided entire catchment in 4 zones based upon the spring density. You can see that zone 3rd and zone 4th is bigger in area, but zone 1 and zone 2 is smaller in area. That is due to the spring density, which we have derived from Survey of India topo sheets. And each zone is taken care as surveyed by an individual field worker. And these are some field activities: geotagging of springs, some water quality analysis, transfer of data from GPS to our laptops. And we also involve the local people so that we can get the right information from the local people. And local people are very happy, because first time they are seeing that government of India is taken care of their springs. Even a small springs is mapping by the government. And we have established rain gauge at 8 rain gauge at different altitudes. There are 2 purposes of installation of these rain gauges. First is measurement of daily rainfall, and second is tracing the isotopic signature of rain, because isotopic technique is very immense significance in identification of recharge area and identification of the source of the spring. So these are some field activities for collection of rainwater for isotopic analysis from different rain gauge sites. And then we have developed a local meteoritic water line based upon collected water samples of last year. And actually this LMW is very helpful to identify the source of the springs. If spring discharge data lies on this LMW, means the source is local precipitations. So we can directly go for altitude effect, that how much the altitude of the recharge area of springs. But if there is some deviation from this LMW, this means there is some evaporation or condensation effect. Means the recharge from a lake or glacier or some water bodies. So this kind of isotopic analysis is very helpful to identify the recharge area. And most important, we have all the collected information we have transformed in GIS platform using different open source technology like GeoServer, HTML, JavaScript, and with the help of internet, we have to store or create or assess all these collected data so that a stakeholder or a person can get information about the springs, more than 35 parameters on a single mouse click. And now I will I will show some geotag, Google Earth view of some geotag springs, and then we'll give the demonstration of our web portal. Is it visible? This movie is visible?
Yes, visible.
Yes, it is. It is visible.
It is movie format or still picture format?
It is moving.
Okay,
Just
great.
slow speed.
Great. These are the springs of the entire Ravi River catchment. You can see that this is a very tough terrain, but our team has done a lot of very hard work to identify each and every springs of the catchment.
Just a quick question, Dr. Rawat.
Ma'am, shall I present my web portal?
Yeah, go ahead. But I just wanted to ask, with
Yeah.
some, I think you have tagged pictures. With others, you don't. Is there a specific reason for that?
Yes, ma'am.
With some locations, you have tagged pictures, it seems.
Yeah.
And with others, you don't. Is there a specific reason for that?
No, all springs are geotagged, ma'am. All springs. There are 623 springs, which is
No. I know they're geotagged,
Sir,
but
Can I answer it? Can I answer,
Yeah,
sir? Rawat sir, can I
please.
answer?
Yeah,
Yes.
why not?
Yeah, ma'am. Ma'am. Actually, we have displayed those photos on Google Earth. So actually, what is happening for some places, there are information in Google Earth, like village names are there. However, we are not showing any name with those photos. So those village names are separate. That are not, inclusive of those springs. So when we open Google Earth, we find name of certain places, right? So those name has nothing to do with our photos.
So what are these
Am I clear?
photos? What are these photos for?
Ma'am, these photos belongs to spring of that particular area. So it is possible that when we are seeing a name, say suppose there is some name says Hati. So in that Hati, that point would denote some village name, and in that village we might have 2 or 3 springs, right? So we may be seeing one name, but there would be 3 photos. So we could have turn off those names in our Google Earth setup, but we just kept it open so that people can get to know that this springs falls nearby which place, and if their place is nearby the spring which we are showing. So in that particular image, we have nothing to do with photos, but we have all the information regarding village name, gram panchayat, districts, and all. So that I think Dr. Rawat will present during the demonstration of web portal.
Okay, please go ahead.
Now this is our web portal. Ma'am, it is visible?
Yes, it is visible. It's visible.
You can see that there is a mobile marquee on the top of the website that is developed under a purpose-driven study. It's sponsored by National Hydrology Project, Department of Water Resources, River Development and Ganga Rejuvenation, Institute of Jal Shakti, Government. So the name is Information System of Himalayan Springs for Vulnerability Assessment and Rejuvenation. That means Ishwar. So there are different. You can see there are different layers in this web portal. That is OpenStreetMap. You can make it visible or invisible, all these street map, so that you can see which springs is near at what location. So there is also a country boundary. You can see our state and country. And there is also river catchment, Ravi river catchment, the boundary of Ravi river catchment. You can make it visible or invisible. And there is also a measuring tools so that you can measure the distance between two springs, and you can measure the area of a particular, how many springs in a particular area. And there is a get information tool, get features upon this. When you click on this, if somebody is interested to know particular details of a springs, so just click on that springs. You can see the geotag image of that springs. We have given spring ID, and the date of survey is September 2018, and the time is morning time, 9:46, and the discharge of this spring is 300 LPM. This is a big spring, big discharge springs. If somebody is interested to more detail, go in few more details. You will get general informations and demographic information and water quality information. This kind of information is there. Just click on general information. You will get what is a spring name, local name, means the blaze name, and the type of springs. It is Nadu. Nadu means Himachal people call it Nadu and Baudi, or some people Paneru, Panera. So this is Nadu. Actually, this is Nadu. And nature of spring means this is perennial springs. There is no landmark near this springs. There is a latitude of spring, longitude of springs, and the elevation is 2361 meter. It is a very high altitude springs. The village name is Kund, Gram Panchayat Pargula, Tehsil is Barmor, district is Chamba. And so if somebody interested to demographic information, the land ownership of spring is government. It is very important. If somebody interested to revive a springs, and if it is located on private land, so we cannot do anything on private land. We cannot do any kind of intervention on private land. So this kind of information is very important. And land ownership upstream of spring, that is also government. And land use at spring vicinity, that is forest, means this spring is inside the forest. And land use upstream of spring is forest. Please mute your mic. And number
मैं आपको और एक बार फॉरवर्ड करो ईमेल से.
Prasad sir, please mute your mic.
Dr. Prakash, kindly mute your mic.
Yeah. And number of dependent village, there is only one village dependent upon this thing. The household in that village is 39. And number of dependent population is 1.
Secretary has joined us. So welcome, sir.
Thank you very much. Good morning to all of you.
Good morning, sir.
Morning.
नमस्कार सर.
नमस्कार त्यागी जी, कैसे हैं?
सर बढ़िया है. ठीक सर.
चलिए कंटिन्यू जो आप कर रहे हैं तो कंटिन्यू कीजिए.
Honorable Secretary sir, good morning sir. Myself Sovan Singh Rawat, scientist at National Institute of Hydrology. I am presenting the web portal which we have created under a purpose-driven study under National Hydrology Project. And the name of this portal is Ishwar, because these springs considered as sacred places in entire Himalayan region. These are called as abode of God. So we have given this name Ishwar, means information system of Himalayan springs for vulnerability assessment and rejuvenation. So this is the web portal, and I have, if somebody is interested about a particular springs, so we can just click on that springs. So this is the picture of that springs, and this is spring ID, and the date of survey is September 18, and survey time is morning, and the discharge of this particular spring is 300 LPM. If somebody is interested in more details about this spring, so just click here. You will get three kind of information. That is general information. demographic information, and water quality information. So in general information, the spring name is Tarang, and type of spring is Nadu. This is basically a local name, sir. In just suppose in Uttarakhand it is called Dhara or Naula. In Himachal it is called Nadu, Baudi, Chirau, and this spring is basically perennial springs, and the latitude of spring is this, the longitude is this, and elevation of this spring is 2,361 meter. Means this is this spring located in high altitude areas, and the place name is Kund. Gram Panchayat is Pargula, Tehsil is Bharmor, and district is Chamba. And this about the demographic information, that what is the land ownership of springs, because this is very important, sir. When somebody is interested to revive this particular spring, and spring set is located on private land, so it is very difficult to revive that spring. So this kind of information is very helpful to the whole land department or some academic institute or NGO which is really interested to revive any particular springs. So at this springs, land ownership is also government, and land ownership upstream of spring is also government, and land use at the spring vicinity is forest, means this spring is inside the forest, and land use upstream of spring is also forest. So this spring is very good for revival, because it is everything is in the hand of government, and there is one place which is dependent upon these springs, and the population of that there are 35 households in that particular place, and the 150 people dependent upon these springs, and 150 livestock dependent on this spring, and the dependency level is very high, because there is no other source of water like pipe water supply or other spring. So dependency level is very high. So purpose is drinking, washing, bathing, and cattle. Other source, there is only one stream. There is no pipe source, there is no other stream, there is only one stream. And people perception about discharge of the discharge is increasing or decreasing. The people perception is that the discharge is moderately decline, and the people perception about discharge, what is the peak month of discharge, that they told that July, August, the discharge is in peak, but in lean season discharge, they don't know in which month the discharge is lean. And the name of information provider is there, because if somebody interested to revive that spring, he can call Gram Pradhan. Even we have given Gram Pradhan name and their telephone numbers in some spring. And water quality spring, this is the main important water quality parameter, which is very important for mountain spring, that taste, color, odor, temperature. You can see even September, there is temperature 12.5%, 12.5 degree, which is very low. pH is 8, EC is 299, alkalinity, silica, iron. Iron is very, very important for mountains, because there are some problem of iron. But in this particular spring, there is no detection of iron. Sodium, potassium, calcium, magnesium, carbonate, bicarbonate, chloride. Fluoride is also one of the very important parameter in Himalayan area, because there is a problem of fluorosis in Himalayan areas. So we have also measured the fluoride, nitrate, and sulfate. So just a single click, we can get the information about the springs. We can get another springs. Suppose somebody is interested in nearby Chamba.
तो आपके पास कितने springs के information है? What is the area which has been covered under this? Is it a particular district or a?
Sir, this is entire Ravi River catchment of Himachal Pradesh, which is
entire Ravi River catchment. Okay.
The area is 5,400 square kilometer, which is about 10% of entire Himachal Pradesh. So till today, we have surveyed 800 springs. Out of 800 springs, 623 springs are on web portals with their detailed information. More than 35 parameters we have given on our web portals. Just one click of mouse, you can get more than 35 parameters of that particular springs.
Okay, carry on.
So this is, suppose this is Chamba.
No, there is no need to show more. You have shown one, that's enough. Yeah.
Okay, sir. And this is, we have given about project, what is the overview of project, background, that I have already discussed in my presentation. Study area, what is different photograph about the study area. And this objectives of the project, and the methodology we have adopted in this project. I call this cubic meter approach. M for motivate people, M for mentor the spring site program, and M for then monitor the performance of the people so that they can revive their spring themselves. So we call this cubic meter approach, sir. And this is the work plan on different activities of this project. And this is about this is project team. And sir, this Himachal Pradesh Jal Shakti Vibhag is the one of the partner of in this project, sir. And there is some infographic tool. We have introduced some infographic tools. Madam, we can get very good information. Suppose if somebody is interested in low discharge springs, so how many springs having 5 to 10 LPM discharge? We can see from this graph. If somebody is interested in big springs, the discharge is more than 100 LPM. That how many springs which having discharge more than 100 LPM or more than 300 LPM? Same is.
Yeah, Mr. Rawat.
Yes, sir.
I'm VV Rao from NRSC. The Survey of India long ago mapped 224, springs in the same area. So
Yes,
have you noticed how many of them are dried up, or the status of those springs, when compared to the present study?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Few springs have been dry up. In the last time when we observed, we surveyed 424 springs. So almost 50 springs have been dry up out of that 24 springs. But now we have data of 800 springs. So we can observe this kind of data in the latter part of the project.
Yeah, thank you.
If somebody is interested in elevation zone, that how many springs in higher altitude areas, how many springs in lower altitude areas. So this information can get from this graph. And how many villages are depend on a particular springs. From this graph you can get this information. And level of dependency, that there are 200 springs where level of dependency is very high. And land ownership of springs, you can see that most of the springs, about 69% of the springs on government land. Same land cover type of system of springs. And same way, electrical conductivity of springs. Most of the springs between 200 to 400 electrical conductivity value. So this is very good for, as per WHO norms, this is very good for health. So this kind of information you can get just a click. We are trying to customize, we are trying to develop this tool so that people can customize this information as per their needs. So there is a gallery, that spring gallery. You can see different springs. Water quality lab. We have developed a basic water quality lab at our Jammu Regional Center, that is developed under NHP PDS. Some field investigation photo is there. Some training and workshop. We have conducted some training program in Ravi River catchment. So this is all about this GIS web portal. Okay.
Can I ask a question?
Yes, sir. Good morning, sir.
Good morning. Good morning, sir. Yeah, just couple of quick questions. I mean, one is more of an observation. So I did a back of the envelope calculation in terms of 800 springs over just over 5,400 square kilometers, which means you have a spring density of one spring for every 650 hectares. Now that's what it works out to. My own, right? Is that right? Yeah.
Right, sir.
So my own observation with regard to Himachal or Uttarakhand from the last, whatever, 10, 15 years, is that, wherever we work, we've actually found one spring for at least for every 100 hectares.
Okay, sir. Right, sir.
So I think essentially you probably are looking at springs that are being used for, used by society. And I think it might be useful to put also on the portal in terms of, so for how many springs are there actually for every single spring that is used? Because we don't want an inventory of only the used springs. In the Western Ghats, for example, where I work, where we've started work very recently, when we talk to people, we find people saying that for every spring that we use, or for every spring from which we draw water, there are at least 5 other springs that are not used. And it might be useful to bring that context into the inventory, in sort of trying to see what is the real number. Because you actually made a very significant comment early on when you say that springs contribute to base flow. And I'm sure there are springs which are not used, which contribute significantly to base flow. And it might be useful to also look at spring shed management a little beyond water supplies. And that's the only reason why I made this comment. Now, the other thing would be to also integrate, I'm sure you have that information, is to also integrate a little more of the geological information. Because you've done it altitude-wise, you've done it latitudinally, longitudinally. And if you can bring in at least some broad information on the geology, because I'm sure you have information on the geology for this area. So if you can also build that information into the web portal, even if it's broad maps, layers of geological maps on which you overlay springs, that would be another useful contribution through the portal. So those were my 2 comments, but I think it's a very good effort on the whole. Thank you.
Thank you, sir. You are very rightly said. And I have learned a lot from you during our Niti Aayog working group. And sir, first of all, I would like to clarify some points in this presentation, that we have not yet completed entire Ravi River catchment. Still, lower part of Ravi River catchment is still left. It is basically the inventory from 3,500 square kilometer. It is not from 5,400 square kilometer. And secondly, we have surveyed up to 3,000 meter. We did not go beyond 3,000 meter because there is a lot of problems. There is a snow-covered areas and very dense forest. We have limited manpower. We have only 3 field strength. So above 3,000 meter, we did not consider that spring in this inventory. But in lower 3,000 meter, we have considered almost all spring. Either it is useful for the people or useful for the blaze or not. Most of the about 90% springs, which is either useful or not useful, we have covered this in this inventory. So this is an inventory from almost 3,000 square kilometer, because most of the part of Ravi River catchment, especially this Chamba district, the altitude of Chamba district varies from 400 meter to 6,000 meter. So we go up to only 3,000 meter. So this is the inventory from 3,500 square kilometer. And second is geology. Sir, you are rightly said, because geology is the genesis of spring. Geology is a very, very important component in spring. We have learned a lot of from you. And in another project that is taken under NMHS, we are considering the different geology layer. But in this project, we will create detailed inventory for some selected vulnerable springs. For that, we have already hired some geologists, and that geology part we will do for only selected springs. Thank you, sir. Over, sir.
Dr. Rawat. Dr. Rawat, this is Suresh from CWB. Hello. Dr. Rawat. Am I audible?
Yes, sir. Yes, sir.
Suresh sir, you are audible. Kindly continue.
Okay. Sir, I have a couple of questions. One is the first part is you are divided into zones. Zone 1, Zone 2, Zone 3, Zone 4. What was the criteria for delineation of the zones? Whether the spring shed this thing divide is used or something else you have used, administrative part. This is the first question. The second one is have you done anything? Basically, it's a issue is about vulnerability of mapping, vulnerability of the springs mapping. Have you identified any spring which are vulnerable? 2. Third question is you are talking about mapping the springs up to 3000 meter above mean sea level. Suppose if you can have an area where you have some streams coming from above 3000, it is perennial, that could be the indicative of the springs having higher altitude. So because it will be very difficult for you to go up, at least you will be able to say that there are springs which are yielding water coming out of the system. And second thing is, as we have so many springs in this one, it is going out as a discharge. Is there any way that we will be able to find out what is the total quantum of water available in this area, out of it this much water is going out as the spring flow? Thank you.
Thank you very much, sir. The first question is about how we can divide different zones. So that is totally depend upon the spring density which we have taken from Survey of India topo sheets. If there is spring density is very high, so zone is small, so that a single person can cover that area. If there is a spring is sparse, so that zone is the area of zone is big, so that a person can survey less number of springs in a bigger area. So that is basically Survey of India topo sheets is the basis of divide entire catchment in different zones. And second question is about vulnerable springs. Sir, we have one objective to identify the vulnerable springs based upon some hotspot analysis. Actually, whatever the information we have collected, we will give some score, 1 to 10 scores. That suppose if in a village, suppose there is only one spring, there is no other source of water, so their dependency is very high. So it will be, the ranking will be very high, means we give 10 out of 10 marks or 10 of 9 marks. So this kind of, with the help of this kind of hotspot analysis, we will give different scores based upon different information collected. And based upon that, we will decide that these springs are vulnerable, and we will develop some adaptive measures, which springs having very high social importance. In some springs, we have seen that in some springs, there are 5,000 people dependent. Even in Bharmor area, there is one spring where 5,000 people from 10 villages are dependent on that spring. So their vulnerability is very high, because if this spring will die in future, 5,000 people will be suffered from dying of that springs. So this is about the vulnerable springs. And next is, we can do some water budgeting, but this is not mandate of this project, that we can see that how many contribution from springs or how many contribution from surface runoff. This kind of study has been done in earlier, but they have done large scales, like for Ganga Basin or Satluj Basin or some Indus Basin. Over to you, sir.
Can I add some questions?
want the community to participate so that raise the question which are unknown springs because
Some audio problem, please. Audio.
Dr. Rao, you are not audible.
Rao sir is not audible, sir. Rao sir, your voice is not clear.
I think I'll request other participants to kindly put your mic on mute.
Hello, Dr. Rawat. Hello, I'm SP Rao from Glacial. Am I audible? Hello. Hello.
Some disturbance, please.
Yeah.
Sir Ashok
Hello.
Raina, can you mute your mic, please?
I'm SP Rao from DHU. I'm audible. Audible.
Mr. Rai, your voice is not clear.
Yeah, okay. So now my voice is coming.
Yeah, it's clear now.
Yes, sir. Now it is.
Okay. So first, I would like to appreciate the work carried out by the Dr. Rawat. Really, it is a very nice work, and you have initiated a good work in the area of the spring hydrology. So, I have one suggestion for you. As you are mapping up to the altitude of 3,000 meter, it means you are in the rain-fed area. So streams originating in the rain-fed areas are sustained by the base flow, and that base flow is supported by the springs. Okay. So what you for your covering to the maximum number of springs as suggested by the earlier earlier Dr. Kulkarni. So you give your more attention to the watersheds, to basins which are the perennial basin, small watersheds which are the perennial. If stream is a perennial, first order, second order, third order streams are perennial, it means that these springs are fed by the streams are fed by the springs, and it means their density of the springs are probability is more. So you take the help of the Survey of India topo sheets where all the perennial streams are shown, and your technicians, your field assistant can concentrate more on those watersheds, so they will get more springs in that area. So this is my suggestion to you.
So thank you very much for suggestion. Sumit sir, please go ahead.
Yeah, Dr. Rava, that was a very wonderful presentation. Just a quick thought, like what the other people have been sharing, that you need to like increase the number of springs and capture number of springs. Just working in this area from last 8 years, I have been. It would be good to work with the local field organizations. I can give you an example of the Spring Atlas, which has been developed by Chirag and PSI. So all the big organizations who have been working in springs area for many, and it's around 1,000 springs in the Western Himalayan region, especially in Kumaon side and all, has been put together. So I'm very sure there are field organizations which are basically working in the Ravi Basin also, and you can also use that information and put it on your Ishwar web portal. That is something which will help what other Dr. Kulkarni and all they are mentioning about increasing the number of springs which are not been used, right? So that is sort of one of the solution which I think you can really incorporate, that field information gathered by different organizations, put it together into that system. So that is what I can show, and it was on my table only. So if you see here, it is a Spring Atlas which has been developed by the PSI, Chirag, and other under the Argham sponsored project. So see, it almost covering the 1,000 springs. So that is one suggestion. Another, being from a hydrology area, I have a quick query regarding your discharge. One thing is like how often you have been measuring the discharge, because when you have characterized the springs under different LPM categories. So how often, what type of data you have already collected so that you can characterize that? because there is a very significant effect of the rainfall which has happened 5 days before or 10 days before. So that is something which I would like to maybe you think about it. Another thing is, like, the last question is about, we normally work in the springs which are like easy to measure, like these are more dharas. What about the nalas? Have you covered the nala area also in your inventorization? Thank you.
Yeah, thank you very much, sir, for giving very good suggestions. And really, there is a need of well-organized approach to inventorize all these things. As we have already given in Niti Aayog, you are also one of the member of that report. So we have tried to develop a web portal. Let us see that how many people come together to make a common web portals from ministry or government sites, so that every organization or every NGO or every state government departments can geotag their springs, whatever the springs they have. Like you have seen that there is a spring atlas developed by Uttarakhand. So this kind of efforts must be one platform, so that all springs can be on a single platform, so that user can get detailed information of a particular springs in entire Indian Himalayan region. Second, sir, about the discharge. Basically, this is web inventory. This is basically spring inventory. So we have taken one-time discharge. It may be we have mentioned their date. Suppose if it is during monsoon, so it is clear that discharge will be high. So we have clearly mentioned the date, even time. If you see that in a day, within a day, there is little bit variation in discharge of spring due to this diurnal cycle of evapotranspiration. So even we have given time at what time we have measured the discharge of that spring. But in this study, we will take some couple of springs for detailed study. For that, we have monitored discharge, regular monitored discharge, and we will also take your help for monitoring discharge, because you are one of the expert of discharge monitoring equipment. So we will take, especially in this Nala case, because Nala is very typical to measure. That in Dhara you can measure by easily by edge film or simple bucket or watch. But in Nala there is lot of problems. So we can develop a system so that we can measure the discharge of Nala. Thank you very much, sir.
Sorry for interrupting in between. Actually, there's another event for release of the Atlas also. So with the kind permission of chair, if we take up the release of Atlas first, and in the meantime, the participants can put their question in the chat and chat in Dr. Rawat and his team can answer to those questions. And after this release and address by Secretary Sir is over, we can still continue with the question and answer session if participants desire. With the kind permission of chair, sir, shall I request Director NRSC to kindly put forward a few words? Actually, NRSC is our implementing agency under National Hydrology Project, and they are supporting this initiative of NHP for improving the extent, quality, and accessibility of water resources information system. And under this initiative, they have come out with a very useful knowledge product. Basically, they are in the process of developing Glacial Atlas for various Himalayan river basins. In the first instance, they have developed the Glacial Atlas for Indus River Basin. So may I request Director NRSC, Dr. Shantanu Chaudhary, to kindly say a few words about this initiative of NRSC. Thank you, sir. Sir, actually, you are on mute. The NRSC board room is on mute.
Am I audible now?
Yes, please.
Some disturbance.
Please carry on.
Director sir, we are unable to hear you.
Unmute, please.
We are not able to hear. Am I audible?
Yes, sir.
Okay. Thank you.
Yes, sir. Yes, sir.
Yeah. Secretary, Department of Water Resources, Dr. U.P. Singh. Additional Secretary, Dr. Debashri Mukherjee. Director, National Institute of Hydrology, Dr. J.V. Tyagi. Colleagues at NIH, DOWR, NRSC, participants in the workshop, good morning to you all. First, I comment the activity on spring inventory by NIH. The National Hydrology Project is a central sector scheme sponsored by Ministry of Jal Shakti DOWR with financial aid from World Bank. National Remote Sensing Center, NRSC, is one of the central implementation agencies under NHP. The activities are organized into 8 specific projects. One of the activity is Glacial Lake Outburst Flood, GLOF, risk assessment. As part of GLOF risk assessment, an updated inventory of glacial lakes in the Himalayan region is being carried out. The Himalayan mountain region is widely recognized as third pole and contains vast number of glaciers and glacial lakes. Rapid accumulation of water in the glacial lakes can lead to a sudden breach of their unstable moraine dams and result into glacial lake outburst flood, which affects the downstream property and reefs. Knowledge of these glacial lakes seems an outstanding requirement for preparedness and mitigation of such disaster risk and for climate change impact assessment. Considering this important national requirement, NRSC has taken up detailed glacial lake inventory for entire Himalayan region of Indian river basins under National Hydrology Project. About 5,335 glacial lakes of size greater than 0.25 hectare has been identified and mapped in Indus Basin using resource set 2 list 4 MX data. The Indus Basin Glacial Lake Atlas is first of its kind, depicting distribution of glacial lakes, describing their geometry, hydrology, topography, etc. The atlas presents the spatial distribution of glacial lakes in terms of area, type, elevation at hydrological and administrative units. The atlas is a comprehensive and systematic database and useful for regular monitoring of changes in this region. Further, the glacial lake information is immensely useful for GLOF risk assessment, assisting disaster mitigation planning for central and state disaster management authorities. It may be worth mentioning here that NRSC recently contributed to NDMA's initiative on bringing NDMA guidelines management of GLOFs. Upon formal release of Atlas, the generated geospatial database will be hosted in Bhuban and Indiawadi's web portals for access and dissemination for users and stakeholders. Similar exercise is in progress for Ganga and Brahmaputra basins, and corresponding atlas will be prepared in near future. NRSC will continue to provide such valuable information in support of national imperatives towards water and disaster security. Thank you. I now request Secretary DOWR to release the album.
Thank you, sir, for releasing the atlas, sir. As informed by Dr. Santanu Chaudhary, that this atlas will be available on the Bhuvan portal as well as India Varis portal shortly. We'll be putting this on online, this atlas. So now I'll request Honorable Secretary, sir, to kindly say a few words to the August gathering.
Very good. It's still morning. A very good morning to all of you. I'm sorry that I joined this workshop a little late because of some other engagements. Of course, today, everybody basically, whenever you go, everybody talks of water scarcity and how a different data is given that how in our country we have only over 4% of water resources and we have to cater to 18% of country's population, world's population, some 17% of cattle population. A lot of other data is also being given like how our per capita water availability is going down and how the next world war would not be fought over oil and gas, it would be fought over water. Also, people projecting different kind of demands in 2030, 2040, 2050. But I feel that all that data may be correct, but I do not consider that India is really a water stressed country actually. A country where you get more than 1,000 millimeter of rainfall on an average. Of course, we all understand that rainfall distribution in India is fairly skewed actually, both over time and space. Most of the rainfall, what we get is confined to monsoon months. And then also, and you also have areas where you get as much as 5,000 millimeter of rainfall. There are areas where you don't get even a 200, 300 millimeter of rainfall. All that is true. The impact of climate change is there, everyone to see. The number of rainy days are coming down, even though the total number of the total amount of rainfall may not be changing much actually. But I do still I feel that a country which gets more than 1,000 millimeter of rainfall, country which has so many springs. Today we were discussing spring. Somewhere I read that India has something like 5 million springs. I don't know. I read somewhere, and out of that, some 3 million is in the Indian Himalayan regions itself actually. So with this kind of situation, I don't think really that we should call ourselves as a water scarce or water stressed country actually. What is needed is basically a proper management of our water resources. And when I talk of management, I talk of both a supply side management and demand side management. Now, I would not be talking in general about the water, but I just heard maybe partly I could not see the whole presentation. But then something of the springs and the spring said spring rejuvenation or the spring said development is not something very new to me. As most of you know, I have been here for quite some time now. I have completed now 3 years as Secretary of Water Resources, and prior to that also I was either DG NMCG or Additional Secretary. So I have read quite a bit on springs right from their importance. I don't think this kind of a gathering need to be told what is the importance of a springs actually. There are certain data, of course, are there that how some 15 or 20% of population in the country, their drinking water needs are primarily met from the springs actually. I read somewhere that when we talk of Ganga and we talk of basically Bhagirathi, we were told that 60% of water contribution in Bhagirathi comes from basically springs. I have also read that some of you were member of that working group which the Niti Aayog has constituted. I have read that report also where it was said that how I think almost 50% of our springs either have either dried up or they have become from perennial to seasonal actually. So somehow both the inventory of the springs and then a national program to rejuvenate the springs perhaps is the need of the day actually. Now I find that a lot of work has been done on spring, both on it's preparing a kind of a not a national atlas. I'm not very sure that still we have a national atlas on springs, but in a smaller way, lot many non-government organizations, lot many states have worked on it actually. And there have been certain work also both by government and non-government organizations on a rejuvenation of these springs. I remembered, I think it was March 2019. I have traveled to the beautiful town of Dharamshala, where we had organized a one-day workshop on both on basically inventarization of springs and the spring set development. And quite a few government organizations, quite a few non-government organizations, and some other experts had also come. And I think, if I remember correctly, some more than 10 papers were also presented during that workshop. Now, perhaps what I feel, and some of you were suggesting also, that people are doing their work in their own way, but perhaps the entire information is not available at one place actually. So there is a need. I remember after this working group, some kind of a proposal was submitted, if I remember, by Survey of India and something to prepare basically a spring atlas for the entire country. And what happens sometimes is if the project is very costly, our ministry, one ministry would hardly have any budget provision actually. Even though water resources is such a big ministry, our budget provisions are something like 7,000 crores or so per year, and a large amount of that is committed expenditure actually. So a lot of work has already been done. So one is, of course, putting all that work done on one platform, and then of course identify the gaps and work on that gaps actually. For example, I remember sometimes back, I think this February this year, Mr. Arjun Munda, who is I think Tribal Affairs Minister, he I remember from Bhubaneswar, he launched something called 1000 Springs initiative or something. That program also, maybe that must be funded by Tribal Affairs Ministry, I'm not very sure, but there also the similar kind of thing was there, that about 1,000 the similar kind of a web-based, GIS-based a web platform where there would be information for about 1,000. And I'm sure that it would not be only an inventarization, but there must be a program in Tribal Affairs Ministry to provide basically a drinking water needs of tribal community or something. Similarly, some of the organizations' name was taken right now. Himothan was one, Himalayan Seva Sangh, Chirag, of course, someone just now mentioned. I think Mr. Kulkarni is there from Aquadam. I heard him actually. So Aquadam has done a lot of work. Argyam has done a lot of work. There Himalayan Seva Sangh. There are a number of non-government organizations, mainly of course Indian Himalayan region, but also as Mr. Kulkarni was talking, certain works have also been done in Western Ghats. Similarly, I find that most of the hilly estates have done some work or the other. I remember presentation was made by Sikkim then also. They also have, I think, a web portal, and they also had this Dhara Vikas or whatever they call. Similarly, I have found that even West Bengal has a program for their 4 hilly districts, Meghalaya, Nagaland, and of course, I'm sure that both Uttarakhand and Himachal must be having. Similarly, we have also been funding some of the organizations, whether it is, for example, National Mission for Clean Ganga has funded IIT Roorkee, if I remember correctly, for taking up river rejuvenation of some one district or whatever it may be in, I think it must be in Uttarakhand, some district in Uttarakhand. So similarly, Survey of India is doing, so a lot of people are doing a lot of work as far as, so one, I feel that there is a need to basically one nodal agency, may not be ministry, but maybe one agency either into the ministry or organization like Survey of India could be one who could kind of collate all the information and all the work which is there, and maybe the kind of portal which NIH has created for one basin, actually a Ravi basin, a similar kind of a portal with those detailed information would be available for the entire kind of a country, which would mean basically, I do not know how many, about 10, 12 hilly states and some hilly districts. And thereafter, of course, that is one is the information. Information is required because someone was asking that maybe something was there today, but it may not exist after some time, it gets dries up actually. So some kind of a baseline should be available with us. And thereafter, I feel perhaps our ministry only, right now, I don't know whether Ministry of Finance will agree for a new scheme, but perhaps we need to have a comprehensive national scheme on spring set development. But if that is not done, that does not mean in the meantime we should not working. It will be good to have a national scheme, but till the national scheme comes, its own ways. For example, let's say NHP has funded this kind of a study. So similarly, there are sources of funding which could be utilized. Non-government organizations are also sourcing funds from different sources, and they are also working their own ways as far as the rejuvenation of springs is concerned. So I basically feel that we should have two initiatives. One is that all the informations relating to springs, which has been kind of studied, collected by a large number of agencies, should be basically collated and put on one platform and in a manner which would be basically useful and which provides all kinds of information. And the other is that while we keep doing our own way, whatever we are doing for a spring rejuvenation, we should also launch a national scheme. May not be very ambitious to begin with, because if you have a very ambitious scheme, then it becomes very difficult to get its funding actually. So maybe with not such a huge funding, but we can do it. And there's a lot of scope for convergence, I understand. For example, I was told when the Sikkim presentation had been made, even in this ministry, we were told that basically they have taken help from a number of organizations like BRC, GIZ, and some other organizations. As far as some kind of an isotope study, I'm told, is generally required to know what is its recharge zone actually. And once the recharge zone was identified, I was told that the balance work was very cheap. It was not very costly in the sense that they could do that work out of the MGNREGA. Basically, so maybe a convergence of what MGNREGA with maybe some of the knowledge partners like BRC, GIZ, etc. should be in a position, and I'm sure that even the state government should be ready to supplement, and maybe we have a centrally sponsored program whereby we partly fund and partly it is funded by the state government. So with the convergence and part funding from central government and state government, we could work on a rejuvenation of these springs. So I'm happy that a lot of people are working in it, but perhaps considering the importance of springs in ensuring the water security and especially ensuring the drinking water needs of very large population who lives in these states. You know, today we have Jal Jeevan Mission, where we are saying that by 2024 we would be able to provide water, right quantity of water, minimum 55 liter per capita LPCD, a clean water regularly through a tap connection at the household level actually. But for that, it is not only the infrastructure which we are creating which is important. What is important is in my opinion, more important is the source sustainability actually. Where do we get water actually? Because all those distribution pipelines and tanks, and they are all only a dispensing kind of or conveyance devices actually. But water has to come either mostly from groundwater or basically these kind of springs, whatever names you call them, whether you call them, just now it was being talked about the nalas, which have been kind of respected, I'm told, by the people since centuries and maybe time immemorial in states like Uttarakhand. So they are very important sources. So unless we have the source sustainability, a very ambitious program, very laudable initiative like Jal Jeevan Mission may not succeed if we do not ensure the source sustainability actually. So let's keep working, and maybe my ministry should take an initiative how to put everyone at one platform actually and and get most of the data which already have been collected, identify the gap and work to collect those data also, and then start some kind of a national initiative on spring state rejuvenation. Of course, I do not know right now. I also I was requested, so I have released an atlas on glacial lakes actually, because again I have not read much, but a lot of people talk of that how this climate change is going to affect basically the glaciers actually, and what they call a glow or a, and a lot of people feel that this glacial outburst or whatever would become more in future, because everybody talks of that one impact which the climate change will have is basically increasing the both frequency and magnitude of extreme events actually, whether it's floods and droughts, of course we know, but then glacial outbursts, etc. So I'm sure that this atlas which has been prepared by Survey of India under funding by National Hydrology Project would also, sorry, by NRSC, I'm sorry, my mistake. So by again a funding from the National Hydrology Project would also be very useful. So I would not like to take more time right now. It seems that the spring or the presentation on the inventarization of spring in Ravi Basin has created a lot of interest and perhaps a lot of suggestions and a lot of queries are coming. So you can continue. Unfortunately, I'm busy otherwise I would have loved to be present amongst you. So it was happy to be here and listening to a part of the presentation and some of your views and queries. Thank you very much.
Thank you, sir, for your encouraging words and the advice given to us. So we'll certainly work upon it. So right now, for a few more minutes, we'll be continuing with the question and answer sessions. And in the meantime, I'd like to thanks all the dignitaries available in this workshop: Secretary Sir, Additional Secretary Ma'am, Director NRSC, Director NIH, the representatives from the NGOs, research institutes, academia, central and state government representatives, the World Bank officials, our Joint Secretary and Project Coordinator, NHP, and particularly Dr. Rawat from NIH. Thanks a lot for presenting and for attending this workshop. In the meantime, I'll request others if they want to discuss with Dr. Rawat for a few more minutes, that the platform is open. Otherwise, Dr. Rawat can share his mail ID. Queries related to Dr. Rawat maybe sent to Dr. Rawat on the mail ID, or it can even be discussed through telephonically, so that the valuable feedback can be incorporated in this study. Basically, the purpose of this workshop was to get the valuable feedback from the experts working in this field as well as other stakeholders. So thanks a lot for attending this workshop. Everybody who is attending this workshop, once again, thank you. In the meantime, we can continue for 5 or 10 more minutes on this platform.
Hello. Hello.
Yes, sir, you are audible.
Yeah, I am Professor Prasad from GB Pant University of Agriculture and Technology at Pantnagar, is in Uttarakhand. Just for your information of all the colleagues, we are also working on this SPARK project. It's an international initiative from MHRD, Ministry of Human Resources and Development, presently Ministry of Education, and it's an international project. We are working on recharge process of springs and its management to mitigate anthropogenic and climate change impacts for water security. And we are just concentrating on that Kumaun Lesser Himalayan region only. And I'm just happy to say that we are associated with Banaras Hindu University, in addition to our international partners. There is Western Sydney University, Australia, and then University of Melbourne, Australia. So we are working on that one. I think now Professor Basant Maheshwari would like to have some comments Can you please permit, please? He is from Western Sydney University, Australia. He is our international partner. Professor Basin.
Yeah. Hello. Good morning to all. It was a great presentation by Dr. Rawat. And as Professor Prasad mentioned, we are also working on spring, so it will be nice to collaborate. One comment I put in the checkbox was how we can engage community to monitor, and I think that creates their own science, and also they can be part of managing springs. So I would like to put this comment to the group. We have done similar thing for groundwater in Rajasthan and Gujarat through a project called MARVI, Managing Aquifer Recharge and Sustaining Groundwater Use through village level intervention. And I believe engaging local communities, schools to monitor and to understand what is happening can be very useful. So they start owning the problem and owning the solution.
Rakesh, once Raju from NRSC.
Yes, sir.
Sir, if it is rather pertinent, we can make a 5 minutes presentation about Atlas also for the benefit of the participants. If there is a opportunity, we can advise. We will be ready in a couple of minutes.
Okay, we can continue. In the meantime, NIH team can take up the questions from the participants, and then 5 minutes you can enlighten the audience with a tour of your atlas.
Sure, we'll do that in 5 minutes.
Okay, fine.
Hello. Well, Mysore sir, you have rightly mentioned that how we can involve local people for springs and management. So in this project, we have one objective, that creation of para-hydrogeologist. Actually, the purpose of this objective is to the local youth, rural village youth, which having little bit background of science. So we will train to them how they can measure the discharge of springs, how the discharge is varying throughout the year, so that they can understand that discharge is decreasing. So they can by analyzing the discharge of their springs, they can understand that this spring is going to be dry in future, so that they can make some plan that how they can recharge or revive these springs by using some vegetative or some engineering measures in the spring side. So I have heard about your program which you have done in Rajasthan. That was really very excellent program, and in future we will like to collaborate with you that such type of program can be done in Indian Himalayan region. Thank you very much, sir.
Thank you so much.
I think there are no. Are there more questions? Or?
Sir, Kashyap sir,
Yes, sir.
We will send a feedback form to all of the participants so that they can fill their feedback or suggestions, so that we can incorporate that suggestion in our PDS. So
Yeah,
we will
it's
send
fine.
email all participants or delegates of this presentation.
Fine. And you can also mention your mail ID on the chat, so that instantaneously also it is available to the participants if they can, if they want to interact with you.
It's already mentioned. They give on that.
Oh, okay. Fine.
Probably it may take
Dr. Raju, are you ready?
Sir, it may take another couple of minutes. Just we are transferring the file into the system.
Okay, your file is quite heavy, no? It's more than 800 MB.
Not, we made a brief presentation, not
Okay.
the entire atlas. So
Okay.
probably this spring shed discussion can continue just for another couple of minutes.
Actually, I think the questions are now over, so it's up to you.
Okay, just give us just a couple of minutes.
You, Rajuji, you can start with the introduction while how that atlas is made and all that. Yeah.
Yeah. Sir, actually, this I'm audible, isn't it, sir? Yeah. See, this atlas actually we are doing for entire Himalayan river basins. We have made a detailed inventory of 0.25 hectares and above glacial lakes using almost a 2017 to 2019 image database, which is essentially from Indian Remote Sensing Satellite ResourceSat 2 LIS4 multispectral data, which is a 5.8 meters data. We used around 480 satellite data sets ortho-rectified for entire Himalayas, and all entire Himalayas database is completed with around 32,000 glacial lakes have been mapped for entire Himalayan river basin, covering about 9.5 lakh square kilometers, which is covering both the Indian administrative part and the transboundary catchment that is flowing into our Indian Himalayan river basins. As a first step, as part of this, we have finalized the database of Indus Basin, while not only mapping the each glacial lake of 0.25 hectares and above, we have also prepared an exhaustive lake attribute database covering about 21 attributes, which are both hydrologic, topographic, and geological parameters. And this database is systematically created, and we have followed an internal evaluation process. And after quality certification at 2 levels, this has been finalized, and we brought out this atlas, systematically providing a spatial database for the entire Indus Basin. Now, my colleague, Mr. Simhadirao, who is the principal investigator, will make a brief presentation giving the salient features of the atlas with a presentation. Simhadirao, please.
Thank you very much, sir. So it is a cover page of Glacial Lake Atlas of Indus River Basin. The contents are shown here. Introduction, it covers study area, data used, the methodology, the results. The results are presented in terms of entire Indus Basin level statistics. And then we have divided the entire sub-basin, Indus Basin into 9 sub-basins, and then intercomparison of all these 9 sub-basins, and then India level statistics. And then Indian states wise, within Indus, what are the states covered, like Himachal Pradesh, and then UT is covered, and then transboundary region, and then the entire Indus Basin has been covered into around 56 map sheets. The details are shown in later slides. And then an annexure containing a list of total 500,335 glacial lakes along with these important details. So these are just Indus Basin with a background of LIS4 satellite image showing the table showing 9 sub-basins which are along with its catchment area, a total of around 342,000 square kilometers. And not only the mapping of glacial lakes, we have also categorized the glacial lakes into major 3 types and then 10 subtypes. Like for example, moraine dams, the top images showing moraine dam lakes and then ice dam lakes and then erosion type and other glacial lake types. So the total glacial lakes distribution I have shown in terms of their area ranges like 0.25 to 0.5 hectares, 0.5 to 1, 1 to 5, 5 to 10, 10 to 50, greater than 50 hectares, the area range wise distribution, and then all these 10 types wise distribution, and then type wise versus area range, and then elevation versus type. So all these different combinations are also shown here. This is an example just showing entire all major 4 types of glacial lakes along with the backdrop of different elevation ranges of the entire Indus River Basin. Similarly, the 9 for each of these subbasins, 9 subbasins, all these distributions are shown in terms of their area, type, and elevation and different combinations. So this is a total coverage of the entire Indus River Basin, 1:250K SY grid scale, of which 56 sheets are covered, out of which 46 contains the glacial lakes, which are shown in this dotted grids. The entire Indus Basin has been covered in terms of a satellite image and corresponding mapped glacial lakes along with the backdrop of elevation and other thematic data sets. Along with each sheet, what are the glacial lakes contains and their types and their statistics is also shown here in this atlas. So like this, we have 46 sheets covering entire Indus River Basin where glacial lakes are located. Thank you very much.
Sir, as informed by our director, we are going to make this data available on Bhuvan portal as well as India Varies portal with the permission from NHP. And similar exercise is on for Brahmaputra and Ganga basins. In due course, we are going to make available both digital database as well as atlases for the other 2 river basins also. Thank you.
Dr. Raju, I think during the current financial year itself, you will be able to release the other atlas, Brahmaputra as well as for the Ganga Basin.
Sir, Ganga is database is finalized. Definitely, it will be released before March. Brahmaputra, because it is almost more than 60%, 70% lakes are in Brahmaputra, almost to the tune of 20,000 lakes. So QC process is going on. We will make an effort to complete it before March, but it may slightly exceed. That's what our apprehension.
Okay, thank you. So I must congratulate team NRSC for this wonderful knowledge product. And I also simultaneously congratulate team NIH headed by Director NIH, and particularly for this PDS to Dr. Rawat, who has taken this initiative and taken forward this work, which is interesting to a number of stakeholders. Once again, I'm thankful to all the participants August gathering available here, and with the kind permission of the Director NIH, I'd like to close this session. Shall I, sir?
Yeah, sure, Kasabji. I think you can conclude it.
Yeah. So
thank you so much. Thank you.
So we'll be preparing the proceedings for this workshop, and particularly covering the feedbacks received from various participants as well as the remarks of Secretary Sir, particularly on 2 aspects. One is that having one single common portal where all this information should be uploaded, and not only uploaded, it is to be dynamically updated. These springs. Simultaneously, the other remark by Secretary Sir is about the national launching of a national scheme for spring shed development. So we'll see how different organizations can come together and work on this initiative. Regarding the first initiative, we'll also discuss with the Survey of India if something can be provided to them under NHP, and if they can conclude that initiative of bringing the material on one common web portal. Otherwise, we can try through NWIC, which is one of the recently established organizations under Department of Water Resources. This is also under NHP. We'll try to do this thing, and other things by observations by Professor Basant Maheshwari, by Dr. Himanshu Kulkarni, and other luminaries, Dr. Prasad, Dr. Rai. I will be taking care, and hope, as informed by Dr. Rawat, they will be incorporating those feedbacks in their studies and improving that before finalizing the final version. So once again, I'll convey my sincere thanks to all the participants particularly right now NRSC and NIH also, and to the participants for their patient hearing and being available throughout the session. Thank you, sir.
Thank you. Thank you so much. Thanks to all.
Thank you.
Thank you so much, sir.
Thank you.
Thank you, everybody.
Thank you. So Mohit, I'll request you to
Thanks to
close
all.
the session.
Okay, sir.